Okay, so when you first look at it, this problem seems pretty impenetrable because we know how to take the derivative of some number to the x, like 2 to the x, and we know how to take the derivative of x to the some number, right? But we don't know how to do both at once, and so that can make this really confusing. The answer to this problem is a bit of a trick, and it's hard to see, and a lot of these come up in calculus, but this trick actually comes up more than you'd think. Whenever you have x in the base of an exponent or whenever you have x in the exponent, this can tend to come up. So here's the trick. First, let's just, background. E to the ln x, everyone knows, right? This is equal to x. That's kind of how e and ln interplay. Okay, so let's replace this x with e to the ln x, and you'll see why in a second. So I'll omit the d or dx right now. So let's do e to the ln x, and this is all to the x. And these two things here are the same, right? Because we just replaced an x with something that equals x. Okay, so why is this useful? Well, by a property of exponents, we can multiply the x by the ln x. And notice, we're now taking the derivative of something that is a lot easier, because now we just have x in the exponents. And so now we can just use normal differentiation rules. Let's start with the chain rule. So remember, we can set our f of x is equal to e to the x, and our g of x is equal to x ln x. And so now we use the chain rule. We know that d over dx f of g of x equals f prime of g of x times g prime of x. Okay, so f prime of x is obviously just e to the x, because we're taking the derivative of e to the x. And g prime of x, well, let's calculate it really quickly. We use the product rule. So remember, you have two expressions multiplied. Differentiate one of them, say x, and multiply it by the non-differentiated other one. So 1 times ln x, right? And then add that to the other way around. So we differentiate ln x and not x. But notice that ln x differentiated is 1 over x, and we're multiplying by x, so it's just 1. Okay, so ln x plus 1. Okay, let's plug this in. So f prime of, so we have f prime is x, and we're going to replace the x with this part, x ln x. So e to the x ln x times ln x plus 1. And so we can FOIL this, or not even FOIL, but just distribute this and get that it's e to the x ln x plus ln x times e to the x ln x. If we want to simplify even further, which is not necessary, we can remember that e to the x ln x, right? Let me draw that clearly. Equals x to the x. That was our initial trick. And so we can go back to our x to the x here and get it's x to the x plus x to the x ln of x. And that's our final answer.